All right, so this notes is on slope-intercept form, so a continuation of what we did on our last activity. Um, but the purpose of this notes is to give us kind of just more practice. But we should already be kind of familiar with this. You could actually probably go through this with the content that we already know from previous lessons. Anyways, so the section notes is on slope-intercept form. So the two things that is required for this form is the slope, right? Slope is rise or the steepness of a line, typically a fraction, rise over run. We'll just put y equal to rise over run. And then to refamiliarize ourselves, it is the dependent variable. I'll just abbreviate there, over the independent variable. And then it's y over x, or vertical over horizontal, our vertical change over our horizontal change. Okay, so this, nothing new. Y-intercept, this is maybe more recent, more current. The y-intercept of a line is a point on the line that crosses the y-axis. Okay, so we're just going to draw an example here. So if we have a coordinate plane with a y and an x-axis, let me draw like this line right here. Okay, right here, this is the y-intercept. Okay, so although like we see that it crosses right here on the x-axis, right, that's the x-intercept, but we don't use the x-intercept to graph a line in slope-intercept form. We only use the y-intercept as noted on the left side on our guided notes. Okay, and then from here, slope-intercept form, an equation of the line that gives the slope and specifically the y-intercept. Okay, so the formula for slope-intercept form is y equal to mx plus b. The two main parts here are m, which stands for our slope, our b, which stands for our y-intercept. This is a right, like I said, where it crosses the y-axis, but it's really, you can think of this as like a vertical shift, a vertical translation, relating it back to our transformation notes. Now we will always have y and x. All right, here the y is the dependent variable and x is the independent variable. So that's always going to be there, but we'll have numbers and values for m and b instead. Okay, so this is the formal like representation for each letter. But here it says when we graph. This isn't any formal mathematics, but this is like, think of this as just Mr. V's advice. Okay, when we graph, I talked about this before, but I want you to think of M and B using those letters as kind of acronyms here. M stands for how much we move, how much we increase or decrease, and B stands for where we begin. Now, this you won't find in the textbook, but I think when we think about it in this way, it helps us determine where we start and what's the slope from there. Okay, so we're going to go through one example on the front, and then we have 3 examples on the back, total of 4. So let's start with the first one, y equal to 2/3 x minus 5. So it's helpful to write slope-intercept form either above or below it, so you can just identify, right, what is m and b. Right, so that's an aspect in problem solving, is identifying and using our context clues. So m looks like it is 2/3, positive 2/3, and b, although it's 5, it's minus 5, or you can think that's negative 5. Okay, before I graph this, let's look at m. It's a slope and it's rise over run. So positive 2, since 2 is positive, that means we go up 2, and 3 is positive. The run is either left or right. Since it's positive, we'll go to the right. Okay. In order to graph this, right, we use these 2 pieces of information, but we start with either m or b. We start with b because that stands for where we begin. So it's negative 5, right? And negative 5 is our y-intercept. So we have to find where's negative 5 on the y-axis. So if this right here is the origin, right? -5 is not up, it is down. You can count down 5 from the origin, so 1, 2, 3, 4, 5. And then from here, we'll go up 2, right 3. So 1, 2, 1, 2, 3. From that point that we initially put. We can draw the line from there, but I'm going to continue the pattern one more time, the staircase pattern or like step pattern. Up 2, right 3, we'll get a point right here. Okay. Right, we'll connect the dots, but then we'll extend it through the dots and to the edge of whatever grid that we have. But this is the graph of the equation y equal to 2/3 x minus 5. Okay, if you're done with that, go ahead and flip over to the next page. But we'll get to that right now. Okay. I'm gonna set up all three, but I think I'm only gonna graph maybe two of these. Let's identify the m and b for each one of these. Okay. So the slope for this first one, number 2 on the back side, is -1/4. Now, the negative that it's in front of this fraction doesn't mean that both the 1 and 4 are negative. It means that one of them is. You can put the negative with either the 1 or the 4. I always put it with the numerator. So this tells me our rise is -1, so we're going to go down 1. And our run is +4, so we'll go to the right 4. Okay. And then our y-intercept here is +1, so I'll put that there. 2, I'll leave the graph as a you do, so you can graph that. Let me know if you would like for me to check as you're completing these notes, but I'm going to move on to number 3. Okay. Y equal to mx plus b. All right. I'm going to start with b here. B looks like it's a little bit easier to find. It is +3. And then m. M is the value that's in front of x here. Right? I don't see a value that's in front of x, but my question to you is how many x's do you see? We see 1. So the coefficient, which is the number in front of a variable, if it's never written out, that means it's a 1. So I'll put a 1 here. Our slope is 1, but slope has to be a fraction. In order to make any number into a fraction, we put it over 1. So this, we're going to go up 1, right 1, after we begin at +3. So +3 on the y-axis. We're going to go up 3 from the origin. And we're going to move for our slope up 1, right 3. So up, or sorry, what am I saying? Up 1, right 1. Okay. Up 1, right 1, we would go over here. Let's continue it. So although we have all these points that are kind of to the right, upward to the right, we can also go in the opposite direction. So instead of going up 1, right 1, the opposite of up 1 is down, and opposite of right is left. So we can go down 1, left 1. Where we can put all of these points here, and then extend it through all these points, draw arrowheads to indicate that the line continues forever, it's infinite. And there you go, you get the line for this equation, y equal to x or 1x plus 3. Where it has a slope of +1. And then our last one, I'll help you set up, but I'll have you graph. Okay. Y equal to 2x, and it's just that, y equal to 2x. Okay. So the m here is easy to find because it's just 2. We'll put this as a fraction, so 2 over 1. This will be up 2, right 1. Now, when we didn't have a value in front of the variable here, right? We didn't initially have this 1 here. We knew it was 1x, right? 1x, same thing as x. But here we are missing a value, and that is whatever is the b value right here. Okay, that won't be 1 because 2x plus 1 is different than just 2x. Right, this is nothing. What would indicate nothing is just plus and then 0. So 2x plus 0, same thing as 2x. So that means our y-intercept is 0. So where it crosses the y-axis is actually at the origin. But I'll leave this graph. Go ahead and try to graph the equation y equal to 2x on the coordinate grid. All right.